Can Helmholtz free energy predict thermodynamic equilibrium? Imagine you're watching a ball rolling down a hill. It naturally moves to the lowest point and stays there. In thermodynamics, systems behave similarly, seeking the lowest energy state. But how do we know which energy tells us where that point is? That's where the Helmholtz free energy comes into play. The Helmholtz free energy is a way to measure a system's capacity to do work when temperature and volume stay the same. It combines the system's internal energy with its entropy, which is a measure of disorder. Specifically, it is defined as the internal energy minus the temperature times the entropy. This means it accounts for both energy stored in the system and how spread out that energy is. When a system changes, it tends to move toward a state where the Helmholtz free energy is at its lowest. If the free energy decreases during a process, that process can happen spontaneously. But if the free energy increases, the process won't occur on its own unless energy is added from outside. At equilibrium, the Helmholtz free energy reaches its minimum value. This is the point where no further spontaneous changes happen because the system is balanced. Think of it like a ball settling into the bottom of a bowl. It's stable and won't move unless disturbed. This idea is similar to how the Gibbs free energy predicts equilibrium at constant pressure and temperature. But the Helmholtz free energy is specifically useful when the volume is fixed. It helps us understand processes in rigid containers or condensed phases where volume doesn't change. Mathematically, the change in Helmholtz free energy relates to entropy and other variables. For example, the entropy of a system can be found by taking the negative derivative of the Helmholtz free energy with respect to temperature at constant volume. This connection makes it a handy tool for predicting how systems behave. In practical terms, if you're working with a reaction in a sealed, rigid container, the Helmholtz free energy tells you whether the reaction will happen spontaneously. When the free energy is at its lowest, the system is at equilibrium, and no further change occurs naturally. So, to answer the question directly, yes, the Helmholtz free energy can predict thermodynamic equilibrium. It does so by identifying the state where it reaches its minimum value at constant temperature and volume. This makes it a key concept for understanding when and how systems settle into their most stable state.